Okay, to start today's video, we're doing chapter 3.1, which is derivatives of polynomials and exponential functions. We're going to do question 3, which is there. It's g of x is equal to 4x plus 7. So, if you remember, you could split this up to get the derivative of 4 of x plus the derivative of 7, because it's being added together and not multiplied. So then, as you know, we can use our power rules, which is 4 to the x, which is going to be to the power 1. This one will come down to make it 1 multiplied by 4, and you're going to subtract 1 from the top, which just gives you 1 multiplied by 4, which is just 4, multiplied by x to 1 minus 1, which is 0, which is just 1. So 4 multiplied by 1 is 4. And then the derivative of a constant, as you know, is just 0. So our final answer for the derivative of 4x plus 7 is just 4. The next question is question 5. It's made to kind of look tricky, but it's really not. You do the same kind of thing. You can split it up because it's subtracting and adding. So this will become, you bring the 75 down, so 75 x to the 75 minus 1 minus, same thing as the first question we did, x to the 1, bring that down, minus 1, and then the 3 becomes 0 because it's a constant. So it'll become 75 x to the 74 minus, that becomes 1, so it's 1 multiplied by 1 minus 1, which is the f prime at x. Okay, so we're ramping up the difficulty a little bit with this question, but it shouldn't be too bad. This is going to be the same as the last two. It's going to be t to the 3, bring down the 3, and then minus 1, just to give you a 3t squared. Now, e to the t is a little bit more tricky. So there is this fun rule where a to the b is going to equal a to the b ln a. So this is in the form of this, as you can see. So we could put e to the 3 is, keep it the same, e to the 3, but this is going to be ln e. And if you know anything about ln e, they cancel with each other. So that's why the derivative of e to the 3 is just going to be itself. So it's going to be e to the 3 t squared plus e to the 3, and that's going to be the derivative of ft. So this next section is s to the t is 1 over t plus 1 over t squared. So to start, we're just going to do 1 over t. We'll work with that for now. So this can be written as t to the minus 1, which is multiplied by 1, but since we don't need it, it can go away. So we're just working with t to the minus 1. So here, we can use the same rule we've been using this whole time. It'll be minus 1, because you bring it down, t, and now when you subtract 1, instead of going to 0, it'll go to minus 2, which gets you negative 1 over t squared, because the negative will go away. Now, we can do the same thing here. This is going to be just t to the negative 2, which gets you negative 2 t to the negative 3, which gets you negative 2 over t cubed. Now putting them back together is going to be negative 1 over t squared plus negative 2 over t cubed. Okay, so next up is question 14, which is a over t squared plus b over t to the 4. So this could be tricky if it's your first time seeing it, but since we did the question right before, we know we're going to assume that a and b are constants, and it's going to be the same as before, where it's going to become t to the negative squared, because when you're taking the derivative, you can just bring any constant outside, and then you can just take the derivative of whatever the variable is. So we know that this is going to be negative 2t to the negative 3, which are going to be negative 2 over t cubed. And now, since it's all done, we can put the constant back in to make it negative 2a over t cubed. And we'll do the same thing for the second part of the question, where it will become b on the outside, and then dy over dx, because we're taking the derivative, or it should be t, but that's okay, of t to the 4. This will become t to the negative 4, sorry. This will become negative 4t to the negative 5, which gives you negative 4 over t to the 5. And then you gotta remember to put the constant back in, which will then give you the r prime of t is negative 2a over t cubed plus, gotta make sure to bring that down, we'll add brackets to make this easier to read, plus minus 4t minus 4b over t to the 5. Question 17. This could be a little tricky if you never worked with square roots before, because I know it was for me the first time I did it, but something that's always helpful is changing it to an exponent to make this x to the 1/2 and making this just x to the 1/4. Because now this should be something that we've seen a lot before, where this will just become x to the negative 1/2, and this can stay to the 1/4, and we'll do our normal routine of bringing down the exponent to make it 1/4 x to the 1/4 minus 1, which it just gets a little tricky because of all the fractions, but it's not too bad. This will become 1/4 x to negative 3 over 4, and this would become negative 1/2 x, gotta make sure to subtract it, negative 3 over 2, which just gives you bring out the negative 1/2, negative 1 over 2 multiplied by 1 over x to the 3/2, and this will become 1 over 4th multiplied by x. It'll be in the denominator because of the negative exponent. It'll be 1 over x to the 3/4. To get you in total, it'll be negative 1/2 times 1 over x to the 3/2. You can put these together if you want to, and you can also leave it in this way. I just want to simplify it and make it look nicer for me, and this will be plus 1/4 multiplied by 1 over x to the 3/4. Okay, now is question 19. So this one might look a little tricky at the beginning, but it's not that bad, because if you remember, this is what the form looks like if you factored x cubed out of x plus 3. So we could just put it back in to make it x to the 4 plus 3x to the 3. Now this looks like something we're a lot more used to. So to find the derivative, we bring down the 4, have the x, and then 4 minus 1 is 3. We're going to skip a couple steps because we've done a lot of them. Plus 3 times 3 is going to be 9x. 3 minus 1 is 2. And you're all done. Now, if you really wanted to, you could factor out the x squared and put it back in the form like the beginning to have x squared 4x plus 9. And that'll be your final answer of the derivative of our original function. Okay, question 23. This one's a little tricky because we've never seen a variable in the top and bottom at the same time, but it's not that bad. So to start, we're going to bring the x into the numerator like always to make it look nice and pretty, which will be 3x squared plus x cubed multiplied by x to the negative 1. Now this is the same as one of the questions before, where you could just put in the x to the negative 1, and from exponent laws it's going to be a subtraction, which will be 3 x, because it would be 2 minus 1, because of the 2 and minus 1, plus x to the 3 minus 1 from the minus 1, which will be 3x to the 1 plus x squared. Now taking the derivative of this is easy because we've done it so many times. So the x to the 1, we know that gets taken away, and it's just going to be whatever the constant is. And this one, you bring the 2 down, subtract 1, gives you 2x to the 1. And there's your derivative of f at x.